Greetings. Today's episode is Hidden Dangers Inside a Boiler Room, specifically steam piping. Stepping inside a boiler room, look at the piping. You're looking for four things: sagging pipes, missing pipe insulation anywhere where the steam piping rises, and drip legs. What am I looking for? Anywhere where water can pool and create condensate induced water hammer. Welcome to Boiler Room Detective. I'm your host, Ray Wolfarth. The sudden interaction of steam and water creates a powerful shock wave that can damage fittings and valves, cause gaskets to blow out, rupture piping, lead to unsafe operating conditions. Condensate-induced water hammer differs from traditional water hammer because it's much more powerful and much more dangerous. Water hammer in the steam pipe occurs when steam traveling at around 70 to 80 miles per hour picks up a slug of water and hurls it against a fitting, valve, pressure reducing station, or steam trap. The kinetic energy generated by the slug of water crashing into the fitting is about 288 joules with the energy of a 22 caliber rifle bullet. The industry expert on condensate induced water hammer is Wayne Kirshner. I'm a huge fan. Condensate induced water hammer occurs when a pocket of steam is abruptly condensed and collapsed due to water or condensate surrounding steam. I know it doesn't sound as severe, but the kinetic energy generated with this is 400 times the energy from a traditional water hammer. It can generate pressures of close to 1500 psi. It's not just a pressure spike, it's a mechanical battering ram inside the pipe. This dangerous phenomenon occurs due to excess condensate in the steam pipe. Let's examine how to avoid it. A sagging steam pipe allows condensate to pool. The steam velocity causes waves to form. If the condensate surrounds a steam pocket, it will condense the steam. Look for broken or missing pipe hangers that allow the pipe to droop. Reattach or replace the hanger and verify the pipe is pitched toward the steam trap at the end of the steam main. The steam pipe should be pitched at about 1/4 to 1/2 inch per 10 feet of pipe. When steam traps were sized to drain a horizontal steam main, the original designer most likely based them on the pipes being insulated. I'm sure there was some sort of safety factor included, typically 20 to 30% oversizing. If the pipe insulation is removed, the bare steam pipe loses 5 to 6 times more energy than an insulated one. That means there is 5 to 6 times more condensate produced. There is no way the traps can handle that high of a load. So we have water sloshing around inside the pipe, ripe for water hammer. To illustrate this, a 2-inch insulated pipe, 100 feet long, will produce about 4 pounds or 1/2 gallon of water at 0 psi steam pressure. If we remove the pipe insulation from the pipe, we will now produce 24 pounds or about 3 gallons of condensate, 6 times more. Anytime the horizontal steam pipe changes to a vertical riser, there should be a drip connection to drain the condensate. This reduces the chance for water hammer and allows drier steam. The last thing to check are the drip leg fittings in the piping. They should be every 100 feet or so to remove the condensate from the horizontal main. The drip leg should be the same diameter as the horizontal pipe. This allows the drip leg to capture the condensate and remove it from the horizontal pipe. It's a good idea to open the strainer once a year or so and blow out the dirt. Also, make sure the drip leg isn't full of water. If it is, the steam trap may be plugged or failed. Condensate-induced water hammer isn't just noise, it's destructive energy. The kinetic energy involved can be comparable to that of firearms or small explosives, depending on the size of the water slug and the velocity of the steam. If you found this video instructive, please like, subscribe, and share. My boiler books are available at Pronto Heating Supplies in New York and online at Amazon.com. My articles are included in these fine industry magazines. Thanks for watching, and I'll see you on the next case.